Lesson 8.8, we're going to talk about surface area, or as the book calls it, solve problems involving surface area. So on page 466, if we look at example 1, they're talking about finding area of composite figures. You have done this before. We did this last year, or maybe a little bit in 5th grade, maybe a little bit before that even. Composite figures when we have a combination of 2 or more geometric shapes. In other words, if they give me something and I can't directly just figure out the area of it and I have to split it up into smaller sections, that's what we mean by a composite figure. So, example 1, a city planner wants all neighborhood parks to have more green space than non-green space. Does this park meet the requirements? All right. So green space and non-green space. We have to split this up because non-green space, I don't know how to find the area of that. Green space, I get the rectangle in the corner there, but I don't get this other part. So we got to split them up. So what we can do, like the book shows you, different ways you could do this. One way, the book shows you a slightly different variation on the green space would be if you go that way. So it's just up to you if you want to do a, like a rectangle and a trapezoid, or like the book does, you can do a rectangle and a triangle, and then the other rectangle. On the other part with the non-green space, the book went ahead and split it up as a rectangle, another rectangle, and a triangle. If you wanted to just do a rectangle and a trapezoid, that would be fine. But one way or the other, that's what we got to do. We got to split it up into, what's the green space, what's the non-green space. We have to figure out the areas, and then we have to add those together. So if you look at your reference sheets for iLearn, none of the formulas for finding the areas of these things are given. So in other words, if you were given this problem, you just have to remember those formulas. So it's kind of an idea when you split this up. Do you want to memorize 2 formulas or 3 formulas? If you only want to memorize 2 formulas, split it up like the book did into rectangles and triangles. That'll make it easier. Okay, so if you've forgotten, for a rectangle, the area is length times width. For a triangle, the area is 1/2 base times height. Or you could take base times height divided by 2, whichever way you want to look at that. Okay, so those are the formulas we'll be looking at as we do this. So you can see over here, this is what they did. So they had, for rectangle A, length times width, they did 14 times 24, or 24 times 14, which is 336. Rectangle B, 24 times 11, or 11 times 24 is 264. And then the triangle, the base and height always meet at a right angle. So you might have to think of turning this sideways and then think about what those dimensions are. So this was 24, this is 24. Okay, so if you take half of 24 times 24, you would end up getting 288. Add those together and you get 888 square feet for the non-green area. We have to do the same idea for the green area. So the green area, they did it a different way in the book here, which is fine. They looked at, what if we had the whole thing, let's see the area of the whole thing, like a big rectangle. So they did 49 times 36, which is 1,764. And then they subtracted the 888 non-green area. That should give you the green area of 876. 876 is less than 888, so technically it's not meeting the constraints of what we want to have. A way to check this, especially if you're doing this on your iLearn test and you have as much time as you want, I would go back and since they did letters, maybe let's call these D, E, and F. I would go back and figure out and make sure that we got the right answer. Or maybe you didn't think to do it the way the book did. You can do it this way. So for D, we're going to do length times width, so 14 times 12. So that's 168 square feet for D. For E, we have another rectangle, so length times width. So 35 times 12, which is 420 square feet. And then one more we've got is F, which is our triangle. So for the triangle, I can see the 24. Over here, see 24. That's the same as this. So for F, it's 1/2 base times height. And that we already worked because that's the same as our other, should be the same as our other triangle. If you're using a calculator, remember 1/2 is the same as 5/10, so you could type it in that way if you're doing it that way. Otherwise, you could just take 24 times 24 and then divide by 2 would be the same as taking 1/2. So that should be 288. And then at that point, it would just be a matter of adding those numbers together. So we had a 168, a 420, and a 288. So we can add those and see if we got the same thing as the book, which they got 876. So when you add those, do you get 876 square feet? Yes. Okay, so that confirms the other way. Or like I said, if you didn't think to do it the other way, I personally probably wouldn't have done it the way the book did it. I probably would have done it this way. And then at that point you can compare and say less green space, so it does not work. On the try it, we have a diagram of an area of a room to be carpeted. Question is, what is the area of the new carpet? Technically, there is a formula for the area of a trapezoid. Again, if it's not given on the reference sheet, that's just one more thing to remember. So might be just as well to split this up. Kind of like it's showing with the dotted line there. Splitting it up as a rectangle and a triangle. So when you're doing this, probably be good to label your workout for what you're doing for A and B. So A is rectangle, length times width. B is a triangle, is 1/2 base times height. So for A, the length and width are given here. Usually we'll consider the bigger dimension to be the length, so 6 times 5. Obviously, if you did 5 times 6, you'll still get the same number. So 30 square feet would be the area of our rectangle. On this, for the triangle, again, the base and height meet at a right angle. So we might consider this to be our base. The problem is I don't know what that is. What I do know is this whole distance across here is 9. I do know across the top is 5. So I guess if we want to put in order our work of our steps here, even though it's a simple calculation, we could show 9 minus 5 is 4. And just mention that that's our base of our triangle. Would probably be a good idea. So 4 is the base of the triangle. The height of the triangle, well, the height is here. That's the same as it is over on the side. So that'd still be 6. And then if you want to, if you have an even number, you can go ahead and take 1/2 of that, or you can just multiply the other two numbers and then take 1/2 or divide by 2. 1/2 of 4 is 2. 2 times 6 is 12. Would be one way of doing that. Or you can do 6 times 4 is 24, and then divide by 2 is 12. Okay, so that's our other piece. And then that's step 3, I guess. And then the last step would be just adding those together. So 30 plus 12 would be 42 square feet.